Okay, so we're going to check out some word problems now that involve solving logarithms. So you see that we have all four of our formulas up here: the growth, decay, the compounded interest, and the continuous interest. So the population of the North Pole is currently 800,000. The population grows at a rate of 1.5% per year. So the nearest year, how long will it take for the population to be 1 million? So we got to kind of understand first which formula we're going to use. Now the population is growing, so we're going to use the exponential growth formula. Now remember what the y equals and the a equals. That little a there, that's your starting amount. The y, or whatever variable is on the left side of the equal sign, that's your ending amount. So this 800,000, that's going to be the little a. The 1 million is going to be the y, because we're starting at 800,000. We want that population to grow to become 1 million. And then the rate is 1.5%, which remember we're going to have to express as a decimal, so 0.015. We can go ahead and start plugging this in. We'll have 1 million equals 800,000 times 1 plus 0.015 to the t. So the exponent here is t because we're trying to solve for how long. We're trying to find out the time. I'm going to go ahead and combine that. So this 1 million equals 800,000, and then that's 1.015 to the t. So in order to get that t by itself, we have to isolate this exponential base. So that means I'm going to have to divide by 800,000 on each side. So in my calculator, 1 million divided by 800,000 is going to leave me with 1.25. So now I have 1.25 equals 1.015 to the t. Remember, in order to undo an exponent, you have to do a log. So if I have an exponential base of 1.015, now I need to take log base 1.015 of each side. So we're going to do log base 1.015, and we're choosing 1.015 as our base because that's this exponential base. And we're trying to use that inverse property there so that these two can cancel out. What you have to remember is that this over here, this is just a number. So we're going to type that in our calculator. Scoot over here real quick. We're almost done. And you're going to type that in your calculator as log 1.25 divided by log 1.015, and that's going to be equal to t because over here on the right side of my equation these canceled out, so that t is what's going to be left. Once you type that in your calculator, now you're going to see that it's about 15 years. It says the nearest year, so we're going to go ahead and say that t equals 15. Okay, so this next one, Santa's trying to save up some money to buy Mrs. Claus a very special, very expensive gift next year for Christmas. If Santa invested $1,000 in a Christmas bank account at 4% interest compounded quarterly. So compounded quarterly, that's right there is my keyword that's going to tell me my formula. Determine the number of years to the nearest tenth required to attain a balance of 5,000. So compounded interest, we see that word compounded. It's not followed by continuously, so we're going to use the compounded interest formula. Now we have to start identifying what the different pieces are. So your starting amount, that P right there, that's the 1,000. The ending amount is that, that was a P I said, okay? The starting amount is a P, the ending amount is that A, and I'm just using the letters that are in the formula there. My rate is this 4%, and we're going to remember to put that as 0.04. Time, that's what we're solving for. That's our variable. And then the last thing we want is the n. So the n is the number of times that it's compounded, and this quarterly right here is going to tell us that n equals 4. So once we figure all that out, now we can start plugging things in. So we're going to have the ending amount of 5,000 equals the starting amount of 1,000 times 1 plus the rate of 0.04 divided by the number of times that it's compounded, which is 4. And we're going to take that to 4t. So now we're going to try to isolate this exponential base here. I'm actually not going to type that in my calculator just yet because a lot of times it doesn't type out and become nice. So I'm going to go ahead and divide by this 1,000 because we've got to get that exponential base by itself. So 5,000 divided by 1,000 will give me 5. And then I still have this 1 plus 0.04 divided by 4 to the 4t power. You could type that in your calculator. You'll see that you're going to get 1.01. But a lot of times it's a whole long line of numbers. So you can go ahead and type that in if you want. You're going to see that you're going to get 1.01. and the exponent is still 4t. So again, we're trying to get that exponent down. We're trying to get that 4t down, so we've got to get rid of the exponential base of 1.01, which means we're going to have to take the log of each side, and we're going to choose log of base 1.01 because of the exponential base. So taking log of each side. So now those inverse properties are going to allow me to cancel this out here. And then this right here, that's just a number. So what I would do is I would type this in my calculator, and I would type in log of 5 divided by log of 1.01. And if you can't leave that in your calculator, you can always use that answer function, and I can show you that in class. Just ask me. So this log 5 divided by log 1.01 is about 161.747. Again, I wouldn't write that down. I would leave it all in your calculator to then divide by 4 and see that t is about 40.4 years. So unfortunately, Santa Claus is going to be saving his money for a long time. Okay, so this last one here, Santa's elves have decided to invest $5,000 in a mistletoe magic CD that pays 6.75% annual interest compounded continuously. So the continuously here, that's your keyword. Compounded continuously tells us we're going to be using that continuous interest formula. To the nearest tenth, how long will it take their money to triple? So we need to understand that if we're starting with $5,000, then that means we're going to be ending with 3 times $5,000, which is $15,000. So as we think about setting this up, that ending amount is that 15,000, that starting amount is the 5,000, and then we have E. The rate of 6.75% is 0.0675, and again, we're going to be solving for T. So the first thing you're going to want to do is you're going to want to isolate this exponential base. So I'm going to do that by dividing by 5,000. So 15,000 divided by 5,000 is 3. And then we have e to the 0.0675t. Now what I really need you to understand is that this 3 right here, that 3 comes from the tripling. Because I could have just as easily said that we started with $1,000. How long is it going to take our money to triple? So that equation would have been 3,000 equals 1,000, and then e to the 0.0675t. First thing you're going to do is divide by that 1,000. And then what's going to pop up is the magic 3. Because of tripling. So sometimes, and we need to be aware of this because this will happen, you will definitely see this, sometimes it's not going to give you a starting amount. It'll just say that Santa's elves have decided to invest money. So we don't have that anymore. To invest money in a mistletoe magic CD that pays 6.75% annual interest compounded continuously. To the nearest tenth, how long will it take them to triple their money? So it's totally irrelevant how much money they're starting with. The fact of the matter is, because they're tripling their money, we're going to end with 3 times as much as we started with. If we were doubling the amount, we would start with 2 times as much. If we were quadrupling, we would start with 4 times as much. So because this is a tripling problem, that's why we're going to have a 3 equals. It doesn't matter what we start with. It's like 1, right? We start with $1 and we're ending up with $3. Then we have E and my rate of 0.0675 and then T. That kind of cuts down on a little bit of our initial work. Now we can see that to get rid of that base E, hopefully you see that you need to take the natural log of each side. So now the natural log is going to cancel out with that E, and we're going to be left with this. And the natural log of 3 is just a number. So you should type in your calculator the natural log of 3, and then it's equal to 0.0675t. So leave that natural log of 3 in your calculator and divide by 0.0675. So we really want to make sure that we're trying to round at the very, 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 very end. So we're going to see that t is about 16.3 years, and we're rounding to the nearest tenth because the directions say so.